All right, so I've been reviewing the discussion board, and I have a really good post that I want to make a video and talk about. Sorry, all I have right now is my iPhone to make this video, so hopefully it's not too shaky and you can get what you need to get out of it. Okay, so here's the idea. The ideal diameter for a certain tire is 570 millimeters. And so a company went out and got some observations to see how close the diameter of the tires were to the ideal. Okay, and so we have the sample standard deviation, and then the sample variance, the sample mean, and the sample median. Okay, and so the idea is now we have to choose which of these is the best explanation of what's going on here. Okay, so the first possible answer is that most tires have the ideal diameter. So are most of these exactly 570? Well, no, only one of them is 570. So right away, that's not correct, right? I have 1, 2, 3, 4, 5, 6, 7 observations. So most would be at least 4. So I only have one that is exactly 570, so that definitely is not correct. Okay, most tires are within 1 standard deviation of the ideal diameter. Okay, so maybe if I draw out a number line, this might help us. Okay, so the ideal diameter is 570. 1 standard deviation would mean that I would go up and down by 3.1623 and 3.1623. Actually, I need to pull out a calculator to figure out what that would be. So this one would be 573.1623. Okay, so I basically have added 1 standard deviation above, and then I need to also do the subtraction. So 570 minus 3.1623 is 566.8377. Okay, now I basically need to know how many observations are within this 1 standard deviation from the ideal. Okay, so if I'm looking here, looking at all my observations, starting with 568, is that in this interval? Yes, it is. Okay, so I'll put a check mark next to that one. Okay, next one's also 568. What about 567? Yes, that's still more than 566.8, so it's still inside this interval. Okay. 572. Yeah, 572 is in that interval. 571, yes, that's also in that interval. 575, that one's not in that interval, right? 575 would be down here, or 565. So that's not in the interval, okay, but 570 also is. So 6 out of the 7 are within 1 standard deviation of the ideal. So that's true, okay? Now, since this is you need to find one correct answer, we could stop. But let's go ahead and talk about why the other ones aren't necessarily true. The variants have too much variance, the tires have too much variance from the ideal diameter. That's letter C. Well, that's, what does too much mean, right? Too much variance from the ideal. That would mean that most of the observations are really far from the ideal, okay? And in this case, we've just discussed how most of the observations are actually within 3.1623, or actually within 1 standard deviation from the ideal. So that's not true, right? So most of the observations are close to the ideal. So that's also not true. The mean and median diameters are not similar to the ideal. Okay, so here's the mean and median. There is the ideal. So no, these are close to the ideal, okay? So that is also not true. Those numbers are close to the ideal. Now, remember you probably from like high school, maybe you've had this discussion about the the bullseye, and it's basically two ways you can be wrong when you're trying to make an estimate, right? So ideally, you want to get it right there on the bullseye every time. You want the diameter of the tire to be exactly correct every time. Now, what you could have happen is that the diameter, when you're guessing, it's all scattered around. Sometimes it's really close and sometimes it's further away. So this is the case that we're in right now, where we're scattered around, but we're scattered around, actually, it looks like we're scattered around the truth, right? Because this is close to the truth. Okay, so that's why this is a good scenario. Most tires are within 1 standard deviation of the ideal, meaning that this is the tires are actually close to what the truth should be. There's also, of course, the scenario where your estimate, you have a bunch of close estimates, but they're not close to the truth, right? But they're close to each other. That would be this scenario like D, where the mean and median are not close to the truth, right? That's a bias type estimator, right? And then also you have this scenario where they're centered around the truth, but they're also just very scattered from each other, right? And so this is too much variance, okay? That's also not the case that we have here, but that would be what you see here in letter C, okay? So this is what we have. That's bias. That's too much variance. If you have any questions about this and want to talk more about it, please follow up in the discussion board.